2010 question number 5. So this one is on curve sketching. So hopefully it looks familiar from last semester. This is the one we kind of concentrated on last semester. So it says the function g is defined. Oh, it's also nice because the other ones are mostly word problems. So it's kind of nice when you're getting just a math one because it helps to explain things a little bit more clearly. The function g is defined and differentiable on the closed interval from -7 to 5 and satisfies the fact that g of 0 equals 5. So there's an initial condition that we need to keep in mind. The graph of y equals g prime of x, the derivative of g consists of a semicircle and 3 line segments as shown in the figure above. So here's the graph of g prime. So we're given the graph of the derivative and they're telling us that the original function is differentiable in this closed interval, and here's the initial condition for that original function. First two, it says find g of 3 and find g of -2. So essentially let's calculate what the original function equals at the value of 3, and then let's calculate it at -2. Now, you'll notice here in my solutions that I actually did more work than I needed to. Again, just a reminder, this one's a non-calculator question before we move on any further. And here are the topics, so you guys can kind of see the topics that are being tested. So I did more work than I actually needed to, and here's why. I actually found the area of all of the different regions, and you'll notice later that we actually don't need to. So I just did it so that you guys can kind of double check your work if you guys did as well. However, I would not do more work than you need to, so I would only find exactly what they want. So for g of 3, you need to take a couple things into consideration. The first thing you need to take into consideration is that we're starting with this initial condition. So remember that at 0, the original function actually does equal 5. So if you thought of it like a graph, if I can pull up a little pen here, if you actually think of g of x as a graph, at 0, it literally goes to the point 5, and then it's accumulating area from there. So it's going up and up and up depending on how much area has been accumulated. So that's something you have to keep in mind, is that the initial condition needs to be added in. So to find g of 3, we would add in the initial condition. We start at 5, and we're adding how much area has accumulated from 0, where we started, because again, it was from 0, to 3. So let's figure out, from 0 to 3, there is an area of pi right here, and an area of 3 over 2 right here. So we add pi, we add 3 over 2, and you simplify that, and you get 13 halves plus pi. So that's the area that has accumulated plus the initial condition to get to g of 3. Alternatively, g of -2 would be going the opposite way. So again, we start from 5, and we're adding the area that accumulates, but now because we're going in the negative direction, we can start at 0, and we're going backwards to -2. And remember, when that happens, that we have to flip that integral to go from smaller to larger, so it becomes a negative right here. If you guys just wanted to jump straight to this one, you can. You don't have to actually write it like this. You can just jump straight to this one if it makes sense to you. I just wanted to show you the two compared side by side. And then the area from -2 to 0 of g prime of x is pi, so it would be 5 minus pi for that area right there. And that is worth, oops, oh my gosh. Oh, it's because I pulled up a pen. Let me get rid of that. There we go. That is worth 3 points. So you get 1 point for using the initial condition g of 0 equals 5, you get 1 point for finding g of 3, and you get 1 point for finding g of -2. Let's keep going. Part B says find the x-coordinate of each point of inflection of the graph of y equals g of x on the interval and explain your reasoning. Now, if you remember our little chart about curve sketching, points of inflection on the original graph on g of x, and if you don't recall this, look back at that little chart again. Points of inflection on g of x are represented by the minimums and maximums of the first derivative. So essentially, if I want to find a point of inflection on the original graph, I have to find all of the minimums and maximums of this graph. So if I come back up here again, I notice that I have a maximum here, a maximum here, and a minimum right here. So the x-coordinates of my points of inflection would be at x equals 0, x equals 2, and x equals 3. So I have 3 points of inflection on my graph because I have 2 maximums and 1 minimum. To justify that, you would say, I mean, whatever you need to say in words in order to justify that, but I wrote, if I can look back over here, I wrote that a point of inflection on g of x is a maximum or minimum on g prime because this is where g prime changes from positive to negative or vice versa. They were a little bit more specific on theirs. So if you notice that theirs, it says the graph has points of inflection at those values because g prime changes from increasing to decreasing at 0 and 3, and it changes from decreasing to increasing at 2. I don't think it's necessarily imperative that you differentiate between the two. I think it's fine to say, it changes from increasing to decreasing as long as you specify which function you're talking about. So notice here they're talking about g prime, and in mine, I said g double prime changes from positive to negative. So just be, clear about which graph you're talking about, and you should get the points for that one. All right, so that's worth 2 points. So we're up to 5 points now. This last part is a little bit more difficult. It's worth 4 points. Obviously, though, remember you only have to get half of the points from each problem in order to successfully pass the exam with a 3. And so getting 5 out of the 9 would be a great start at least. And let's see if we can get any more of the points from this last one. It says the function h is defined by this. H of x equals g of x minus 1/2 x squared. It says find the x coordinate of each critical point of h in the interval from -7 to 5 and classify each critical point as the location of a relative minimum, relative maximum, or neither a min or max. Explain your reasoning. First things first. Critical points. Okay, as soon as you read those words, critical points, it should kind of trigger in your brain that we need to find the derivative of h of x, because the derivative of h of x is going to give us the first derivative, and that's how we can figure out the critical points. So if I find the derivative of h of x, you can see it down here, it would be g prime of x, and the derivative of 1/2 x squared is negative x. So this is the derivative. Now to find the critical points, I need to set that equal to 0. Now because we do not know what g prime of x is, we can't actually solve this equation for x, but we can look at it as a relationship between g prime of x and x. So if you move x over to this side by adding it, the derivative, h prime of x, will equal 0 wherever g prime of x equals x. So wherever the x value is equal to the y value in this function that's given to us, then the derivative of h would also equal 0. So if you kind of look down with me, I know I'm showing a lot more than I am trying to all at once, but I just want to get this up on the page. I like this picture, so look over here with me at this picture. So I just recreated the picture that was given to us. And look at this red line that I drew. This is the line y equals x. Or in other words, y, which is the function we're looking at, equals x. That's what this is. So notice that these two things are supposed to be in relation to each other. Okay, so this line is essentially this red line that I drew. And notice that it intersects my function twice. It intersects it right here, and it intersects it right here. Now this is an easy point to find because it's listed on the graph. That's the point 3, 3. So automatically I can go ahead and write that x equals 3 is one of those points that would satisfy the derivative equaling 0, which automatically means that it's a critical point. The other one, though, you have to actually find using the equation of a circle. So if I know that this circle right here is the equation x squared plus y squared equals 4. All right, so it's centered at the origin and it has a radius of 2. So that's how I get this. Now because I'm looking for where these coordinates are equal, so I'm looking for where x equals y. Remember that this is the line y equals x. So I'm looking for where x equals y. So all I did was I replaced y with another x, so I can actually solve this equation. So I have x squared plus x squared equals 4, which is 2x squared equals 4, divide by 2, take the square root. Notice that I didn't use the negative one, I only used the positive one, and that's because the negative radical 2 doesn't actually fall on my line, because it doesn't equal the same thing. So I'm only looking for the positive radical 2, and that's what I got right here. Now, for the justification, because that's the last part, is looking at the justification. If it were me, if I were you guys, I would kind of imagine this like tilting my head sideways. I'm actually going to take a picture of this to kind of give you guys a better idea of what I'm talking about. So imagine that red line that I drew right there, the line y equals x. Imagine that is actually the x-axis. Let me just get this picture up here so you guys can see what I'm talking about. Alright, so not perfect, but imagine that... Let me pull up that picture one more time. Sorry. Alright. There we go. So imagine that this red line is the x-axis. Okay, so I tilted it so that you guys could kind of imagine like it's horizontal, and then obviously this line is still the y-axis. But here's why I want you to imagine that. If you imagine this red line is your new x-axis, everything that's above the red line would be considered positive, and everything that's below the red line would be considered negative. So let me highlight what's positive. All right, that piece would be considered positive, and this piece over here would be considered negative. Okay, and the reason I want you guys to do that is because now looking at this equation, g prime of x minus x, because essentially that's what you're doing is that you're subtracting x from it. So everything kind of is now in relation to this red line. And so that's kind of what I wanted to interpret down here. I said h prime of x, which is now this function, now that I've tilted it, is positive or greater than 0 between 0 and root 2. So that's just this little piece right here, between 0 and root 2. Notice that we have a positive value because it's above the red line. And then I said that h prime of x is negative in between root 2 and 5. And you guys can see that here, the green one. After root 2, it starts becoming negative because it's below. So remember that on this function, since this is the derivative, wherever it changes from positive to negative, that would be a maximum. So wherever the derivative changes from positive to negative, and again, look at that little chart that we have, wherever derivative changes from positive to negative, that's a maximum. So notice that I put x equals radical 2 is a maximum because g prime minus x changed, and you guys can't see this over here, but g prime of minus x changed from positive to negative. And then x equals 3 is neither a min nor a max, because notice that it's all in the negative. It doesn't actually change back to positive again. So over here at 3, this does not change back to positive. It stays in the negative numbers, which means it's neither a min nor a max. And so you can just write that it's neither a min nor a max because the sign does not change from positive to negative. Now let's look at what the AP writers actually came up with as their answer. So look how long their answer is. Remember, it's worth 4 points, but you can get partial credit a lot. You get 1 point for finding h prime of x. Super easy. That part was like the easiest part. You get 1 point for identifying x equals radical 2 and 3. Maybe a little bit more difficult, but again, I think you guys could easily do that, identifying radical 2 and 3. You get 1 point for the answer for radical 2 with an analysis, and 1 point for the answer for 3 with an analysis. So again, they're showing you that the derivative would be positive when it's less than radical 2 and negative when it's greater than radical 2. So therefore, there's a maximum at radical 2 and neither a minimum nor a maximum at x equals 3. If you could get all of that, that would be amazing. But like I said, I think that the parts that are definitely feasible, especially under a time crunch, like the AP exam, the first 2 parts are definitely feasible for everybody to be able to do. The last 2 parts would require a little bit more skill and a little bit more speed and accuracy as you're going through the problem. But you should be able to get these 2 parts without much of a problem at all.